Let's talk about radicals and rational exponents. So I have some examples here that I want to go over. The first one is simplifying something like this. Now, it is worth noting that for the lab class, even for the quizzes, I do allow you to use the calculator. So if you have the Casio that I recommended you purchase, you can get the radicals for the numbers, not the letters, but just the numbers. Like if I need the square root of 64, you can put square root 64 and it gives you the 8. So you can get the numbers from there. Now for the letters, if it's a square root, what you need to do to the numbers is divide them by 2. So if you do 36 divided by 2, I get 18. So what it's going to be? It's going to be p to the 18. So this, what happens is the square root and the 36, what you do is you do 36 divided by 2. If you get a whole number like we do here, 18, that's going to be the exponent. And that's it, no radicals. The same thing goes here. The square root of 16 is 4. 46 divided by 2. 23. So it's going to be x to the 23. Now, here with the 27, the Casio still works. It gives you 3 square root of 3. Now, what happens here is you do have some radicals. So for like the 27, it will be 3 square root of 3. Now, if you're saying, Miss, I don't have that one. How do I do it by hand? So this is how you do this by hand. So if you want to do 27, you would do 27 and then two numbers that give you 27. Well, 9 and 3. And then two numbers that give you 9, 3 and 3. 3 is already prime, which means there's nothing that multiplies to 3, only 1 times 3. So these are my numbers. The square root of 27 is the same thing as 3 times 3 times 3. Any pairs of the same numbers are going to go outside as a single number. And then if you don't have a pair, you're going to stay inside. So that's how the 3 square root of 3 comes about. And we'll do more examples, and I'll do them by hand also. But remember that you can also put them in the calculator if you have the Casio. The 84 will not do it like anything like the TI-84, which is in a popular calculator that students have. Won't do it because, doesn't want to move. Because like if you put the square root of 27, it will give you a whole bunch of decimals. And you want exact answers for these. So that's one of the issues. I think maybe some of the more, the newer models may do it, but most TI-84s won't. And now for the letters, I told you, okay, so it's going to be 3, let me just do it in 3 square root of 3. Now for the letters, you break them in half, right? So I told you to break them in half. So then this would be x to the 5th divided by 2. Now the 11, you say, well, I can divide the 11 by 2 and get a nice number, right? But 11 divided by 2, how many times does the 2 fit into 11? 5. 5 times 2, 10, and you're left with 1. So your answer will be y to the 5th, and then 1y, because this is a remainder, 1y stays inside. So it's just basically how many pairs can you get. Now you could also see it the way I did with the 27, like for example, y to the 11. How many y's do you have? You have 11 y's. But see, it's a lot of work if I do it by hand. And then you look for pairs of 2's. So pairs of 2's. And how many y's are left? There's only 1 left over. So that's why this leftover y stays inside. All of these y's come out. So it's 1, 2, 3, 4, 5 y's, and 1 stays in. But the easiest way to do that, rather than labeling all the y's, is just the division. How many 2's fit into 11? 5. How many are left over? 1. So then it would be y to the 5th square root of y. Don't leave them like this. That's not how you give the answer. The answer will be putting all the numbers outside. So it will be 3, x5, y5. And inside, we have a 3 and a 1. Now here we have it again. Now we have 2 of them. There's several ways to do this one. It's to the 5th root, not the square. So let's do the multiplications. 8 times 4 is 32. And then the powers, you're going to add them. So this is 1, so it would be x to the 5th. And then y to the 5th. The cast, if you want it, so you're doing each of them separate, remember? So you can still put the numbers in the Casio. To get the 5th root, you do shift and this one right here, and you get something like that. And I can put a 5 there, and then I put 32, and I get 2. Now, if you're going to do it by steps, you would do 32. Two numbers that give you 32, 8 and 4. 4 and 2, 2 and 2. And then the 4, 2 and 2. So what you end up having is 1, 2, 3, 4, 5. And since it's the 5th root, then you're looking for groups of 5. And that's how the 2 goes out. And the same thing with the x's. It would be in groups of 5. So 5 divided by 5 is just 1. So it would be x to the 1. And then y, 5 divided by 5 is just 1. Now, when you write the answer, don't write the ones. Just write like this. Because it's the 5th root. Now, if it's the only one that you're not going to see a little number outside the root is the square. The square doesn't have a little root, so it's always a 2. If otherwise, they will give you a number. Adding and subtracting radicals. So what happens with these is you need to make sure, in order to combine them, you need to make sure this is the same. It is, so then I can just do 12 minus 11, that's 1, and then the square root stays the same. Now, when you write the answer, you don't have to. Now, in a problem like the next one, where they're not the same, you simplify the roots first. So let's say I take the 27. Two numbers that give me 27, 9 and 3, 3 and 3. And this is a square, so we're looking for pairs. So it's 3 goes out, and then square root of 3. Now you do have this here, so I'm going to just bring it over, and you're going to multiply. So this would be negative 30 square root of 3. Now, let's do the 48. Two numbers that give me 48, 4 and 12, 2 and 2, 2 and 6, 2 and 3. So for 48 is 1, 2, 3, 4, and a 3. And we're looking for groups of 2. So this would be 2 times 2. He doesn't have a pair, the 3, so it stays inside. Now don't forget to bring the negative 3 right here. So this is going to be negative 6, negative 12 square root of 3. So my new problem is this one and this one. Negative 30 square root of 3 minus 12 square root of 3. So I combine them. Negative 42, and the square root of 3 stays the same. So again, the first thing you do is simplify each exponent. I say exponent, but I mean radical. Multiply if you have to, and then do the operation if it's possible. And the reason why this one was possible is because the roots were the same. Here's another one. So again, the radicals inside are not the same, so we're going to simplify the 12. 4 and 3, 2 and 2. So we're looking for pairs, so the 2 comes outside. This 3 didn't have a pair, so it stays inside, and we bring this. So this is going to be negative 6 square root of 3. We cannot simplify this one, the square root of 3, so this one just comes directly down. And then we do the operation, so it would be negative 10 square root of 3. Now, on something like this, if you have the Casio, you can actually do the whole thing there. So you can, now you don't even have to simplify, you would just do negative 3. I am not asking you to show me work for these, so it's not going to be a problem if you do it with the calculator. See? But I know some of you, and like I said, the TI-84s and all of those don't have these. In my open math sometimes allows you to do decimals, but most of the time problems like this will want you to do the radical. Now on this roots, the same problem. We all have B's, but the numbers also need to be the same inside the root so that we can combine them. So we need to simplify each of them. And now on something like this, you can also put them in the calculator. Don't put the letters, just the number. Like if I put the square root of 8, see? So I would write 2 square root of 2 and then just bring the B out. And the same thing for all the other ones. You could do it with the calculator. I'm doing it by hand here because I know a lot of you may not have the Casio and you need to do it by hand. So that's the only reason. So for the 8, it would be 2 and 4, 2 and 2. And that's how we got that one outside and then the 2 inside. Now for 50. Two numbers that give me 50, 5 and 10. You cannot break up the 5, the 2 and 5. So you got 2, 5, and 5. So there's a pair of 5s. So the 5 comes outside. Let's carry down the minus. And then 5 outside. And then inside you have the 2 and we still have that B. And now we're going to do the 98. Two numbers that give me 98. Oh, yeah, that's a big number. 2 and 49. Yeah, 49. And then 49, 7, and 7. So I have 2, 7, and 7. So the 7s are the ones going outside. I'm going to put the plus 7 square root of 2b. And now that I simplify the radicals, you can see here all the roots are the same. They all have 2b. So then we can combine the numbers. 2 minus 5 plus 7. And that's going to be 4 square root of 2. This is still addition. Now there's an issue with this one because of the fourth root. So let's simplify first and then we'll take it from there. I'm going to simplify this one first. So the 8, I think we've done it several times already. The 8 would be 2 and then 2 outside and then the 2 stays in. But let's do the letters. This one, x to the 12, we divide it by 2, comes out as x6. 19, the 18 is 9. And then inside you would have the 2 and you have 1y. Now that went by kind of fast, but think about x12. So 12 divided by 2 is 6. And that's how I got that one for the x12. y19, 19 divided by 2. Well, that's going to be, how many times does it fit? It fits 9 because it gives you 18. But I still need one more, and that's where the extra y comes in. Or you can do it like the old-fashioned way, like 19 divided by 2. So that's 2, 18, and 1. The number on top is the one that goes outside. Not the 2, right? It's a 9. The number on top is the one that goes outside, and the remainder is the one that stays outside here, you see? I'm going to erase it because I have a lot of other ones to do. Okay, so that takes care of that one. Let's do the next one. This one is the fourth root, so what we have to do with this one is do it in fourths. I'm trying to think. So because this is the fourth root, when we do it, we're looking for groups of 4. So let's do that 2. There's no breaking that one. That one stays. But 24, you're going to do 24 divided by, I'm going to carry down the divided by 4. So that's 6. And then you're going to do the same thing with the 37. Well, that's going to be 9 because that's 9 times 4 is 36. But that one, you do have 1 left. So that's the fourth root, and you have 2y. Now, be careful there, because see, with the fourth, we cannot combine this one and this one because this is the fourth root and this is the square root. So you got to be careful with that. Let's finish all the simplifying, and then I'll show you how we're going to write the answer. This one is back to a square root. There's nothing we can do with the 2. It's 4xy. But we can do the 10. The 10 would be x5. And then the y, 17, 8, right? And we have 1 left. Like that. So this ends up being 4x to the 6, y to the 9. So when it's time to combine the numbers, we're going to combine the square roots only. This one and this one. So that's going to be, and that's because all the letters are the same. You see that? So that's going to be 6x. Look at the letters. They're staying the same. Now this other one is going to stay as, because of the fourth root. This one is cube root. But since both of them are inside the cube, we can do the operation first. Like here, this is division, so you subtract the letters. So everything is inside the cube root for now. 5 minus 2, 3. 8 minus 5, 3. Now with the 3, you're going to divide by 3. So it's x to the 1, y to the 1. You're dividing 3 divided by 3. So then the answer is just x, y. This one, especially when there's only numbers, the Casio is really good because you can just do the fraction and then you do 15 plus the square root of 27 and then divided by 3. And you get the answer. So I will allow you to do that. But if you need to do it by hand, then you can get the 27 and we're going to break it up. So that would be 3 and 9. 3 and 3. So there's a 3 there. So it would be 15 plus 3 square root of 3. This group makes the 3 outside. This one that doesn't have stays inside. Now, you're going to look at all the numbers outside the root and see if there's something you can divide all of them by. which there is, we can divide by 3. So if we divide by 3, you get 1, 1, and 5. So your answer is 5 plus, you don't have to put the ones for these. Rationalized denominator, that's a word, it keeps coming up. I'm teaching pre-calculus this semester, and oh my god, they have to rationalize so many numbers. The Casio, again, can be your lifesaver here. You can just plug it in here to get the answer. Now, to rationalize means to get rid of the radical on the bottom. So the way you do that is by multiplying by the radical on the top and on the bottom. So what's going to happen is on top, you're going to have 20 square root of 10. Now on the bottom, I cannot multiply the 20 and the square root because one is outside and one is inside. So that has to stay like that. But on the bottom, they're both square roots. So I can multiply them and get the square root of 100. So what happens is the square root of 100 is 10. And then we can simplify the outside portion. This one divided by that one, that gives you 2. Square root of 10. Here's another rationalizing problem. We're going to multiply by the square root of 11. So the only thing you multiply by is the square root. You don't need to do the 14. So then on top, I have 33 square root of 11. And then on the bottom, I have 14 square root of 121. Well, the square root of 121 is 11. So then when I multiply 14 times 11, I get 154. But before I end up putting that big number in there, I can see that the 11 and the 33, this becomes a 3. So my answer is 3 square root of 11. And even if you don't see it, you can still put it up and simplify later. Now, to double check my work, because I do have the Casio and I want to make sure. See? This is another one. Now here, that it looks different because the whole square root. But what you actually have is 2 square roots. Square root of 3, then square root of 13. Now I'm going to multiply just by the bottom square root. So because on top, now I have 2 square roots, I can actually multiply them and get 3 times 13, 39. And then on the bottom, 13 times 13 is 169. Now the square root of 169 is 13. And then that's it. Now, before I say it's the answer, the 39 looks very tricky. I would want to check to make sure there's no pairs. But you can see here 3 and 13 are prime. So, yeah, this would be the answer. Let me double check. Now you can do the problem as you see it in the calculator. Look, I can put square root and then fraction. 3, 13. Ta-da! So the Casio is really good. I know I keep selling it to you, but yeah, I feel it helps a lot, especially if you struggle with these. With the simplifying, it avoids this little tedious work that you do need in some of the problems, but it's not necessarily the algebraic part that we're focusing on here, because we are focusing on functions for the class. So I feel like having the Casio helps to eliminate all these little things. Now, I almost said we are done, but we are not. 2 more questions. Whoa, let's do one more. Now, this one is the 6th root. I don't know what the question is. Let's go to it. No, what happened? I don't know what I'm doing. There we go. Okay, sit there, right there. This is the expression, and they want us to find the powers of each of the letters. So, this is the 6th. So what happens with these is this a rational exponent. You're saying, well, I cannot divide, right? 2 divided by 6 doesn't work. What they want you to do for something like this is to break them up. Like, remember this, each of them has a 6 root. There's a way to rewrite this as exponent. So this would be x 2 over 6. The power on top, the root in the bottom. I remember it because the roots of trees are always in the bottom. So the root always in the bottom. Now do simplify the power if you have to, like here, it would be, this would be x to the 1/3. So they're saying r is the number with the x, so this is 1/3. Now we look at the y, it's going to be the same thing. It's going to be y 2 to the 6, which is the same as y 1/3. So that's how you change roots to powers. In this one, we want to write it, go the other way. We want to change it to a root. So it would be the x inside. The root is always in the bottom, so it's the 7th root, and the power is 6. Roots of trees in the bottom, the powers go on top of the fraction. So those are rational exponents, how to write radicals as fractions and fractions as radicals. So I hope this helps when you're working on the lab. If you have any questions, please let me know.